So in this stage four of PCB layout design, which is the stage four of the embedded hardware design life cycle. Okay,
Okay.
so basically you do all this stuff, right? The component placement and routing and everything you do. But the first thing we need to focus before you do any of the steps or before you take any of the actions which you
Okay.
normally do in your PCB layout design stage is that you talk to your PCB fabricator or your PCB manufacturer first
Okay.
and check if they are able to meet your design requirements. Okay, so what are those
Okay.
design requirements, such as PCB stack up layout, if the number of layers is able to make it or not, what is the minimum trace width requirement or the characteristic impedance, which for high speed signal traces for differential signaling. Okay, all
Okay.
these things, if he's able to manufacture or not, or if he's able to produce or not, you need to check with your PCB manufacturer or PCB fabricator. Why?
Okay.
Because see what happens if you, without checking and you design everything, and ultimately your manufacturer says that sorry boss, we cannot do this, so your all your time, all your effort is wasted,
Okay.
isn't it? So that's why before you do any of these things, okay, first you need to get in talk or get in contact with the PCB fabricator and PCB manufacturer and check if they're able to meet our design specifications. Got it?
Okay.
Okay, so write down.
Yeah, I have taken it on.
In this stage we will get in contact with the PCB fabricator or manufacturer
Okay.
and check if they are able to meet our design requirements,
Okay.
such as PCB stack-up,
Okay.
trace width and characteristic impedances for high-speed signal traces,
Stack up characteristic impedances.
for high-speed signal traces,
Okay.
and then take the next actions of the PCB layout design, and then take up the next actions for the PCB layout design.
Okay.
Okay. So first thing is what?
First thing is what we have to contact with the PCB fabricator
Yeah.
regarding whether it is meeting our requirement specifications, design specifications, such as stack up. We would have finalized the how much layer of PCB should be.
Mm, mm,
Then we are moving into characteristic impedance for high speed signals
yeah.
and traces, and then we are moving to next actions. I have a
Correct.
query here. High speed designs and um, trace with another, why we have to go with PCB fabricator? Because as you are saying that length and width of the traces will be very minimal, if it needed, or maximal, so that they are able to fabricate such type of PCB. That's the reason we are contacting with checking with PCB fabricator.
Yeah. See, in order to why we need to talk to manufacturer is that there are certain materials specifically used for such high speed requirements, okay,
Okay.
to match, and there are certain you know trace width as well as the thickness of the copper foil, all
Mm.
those things are required to attain or to f- you know get the required characteristic impedance. Okay,
Okay.
so ultimately if you do something in your CAD tool and ultimately manufacturer says that sorry boss, we do not support such thickness of the board, such dielectric material we cannot use, it is not there in our system, or is not there in our, we don't have that availability, so that will create problems, right? Isn't it? So that's
Yeah.
why you have to find out the right manufacturer who is suitable for your design. If not, then you can change or design according to the your approved vendor manufacturer, that what layout stack up we can support. Based on that you can design. So either way you can go for it. Got it?
Oh, okay. You told about dielectric thickness. Huh?
Mm-hmm.
So once we decide number of layers, say for example 4 or 6, mm, the dielectric thickness is depends upon our design, or it is depends upon the PCB layout engineer's design. So we are giving the requirement specification for him, like components should be there, and the trace length and width should be there, this much only. So this we are drawing in that arcade diagram and we are giving, and that dielectric between the copper layers, this much thickness should be there, is decided by our end or designer end, or it is into a PCB layout engineer's hand.
It's a responsibility of a hardware design engineer. You as a hardware design engineer, you have
Okay.
to make that decision. You have to come up with that design calculations. You have to make that do the required engineering, okay, behind all the material selection, behind all that copper thickness, or how the layers of the PCB board should be arranged, okay, where
Okay.
should be the power plane or ground plane. All these things anyway I'm going to teach you in going forward
Okay.
classes. You're going to learn
Okay.
that. All
Okay.
right.
Okay. Okay. Yeah.
All right. So like I was telling, when you talk to PC fabricator and you ensure that you have the proper vendor, the next thing you have to do is, first you have to create a board outline,
Okay.
okay, using the CAD tool. Okay, for example, if you have some specific requirement from the customer that your PCB should be in such shape, or it should be of length L and width of certain dimensions. Okay, so what is that
Mm.
board outline that you have to draw in the tool? Okay,
Mm. Mm.
and then import all the components from the schematic to your CAD tool. All
Okay.
right, and do the component placement.
Automatic component placement, right?
Not automatic, there's engineering behind this.
Okay.
Okay.
Some tools I have seen, if you upload the BOM of that schematic of that.
It will, yeah, it will import. But
Yeah.
for example, I'll tell you in short. I'll tell you anyway. You're going to discuss that in more detail going forward classes. I'll tell
Okay.
you. See, normally when you import, all these ICs or components are randomly put in the layout in the
Okay.
tool. Okay, something will be here like this. Okay, then what you do, you bring them near to each other. Okay, so that it will be as per your requirements. So this can, normally what people do is generally, which is
Okay.
a big mistake, that they try to place all the critical components first, and then later on the non-critical components they place it. Okay, that is
Okay.
fine, but doing that they forget that what is the minimum length required between placing those two components. Okay, so let's
Okay.
say if you are placing these two components, okay, and in, for example, now another component is required here. Okay.
Okay. Mm.
Okay,
Okay.
now earlier you have routed these components properly. Okay, but you, because of this component is already first routed, now you have to route this also here. Okay,
Okay.
now because of this, what happened, the length between these two is minimum,
Agree.
but it is not sufficient, it has to be more closer. Okay, but
Okay.
you are not aware about what should be the minimum distance or maximum
Mm-hmm.
distance between these two ICs. Okay, that you need
Okay.
to calculate. That is known as
Okay.
critical length.
Okay.
Okay, critical length of the transmission line or PCB trace. Okay, so that
Okay.
I'm going to teach you how to calculate anyway in going forward classes. Okay,
Okay.
so based on your critical length between the two ICs, the transmission line, okay, you
Mm-hmm.
have to do the component placement. So this is again a detailed engineering which you need to do it. Okay,
Okay.
which
Mm.
normally people randomly place, okay, near to each other, but that should not be done. There are some PCB layout guidelines, okay, and
Okay.
some calculation, design calculation based on your frequencies and power transmission and characteristic impedance. Okay, you need to place these components properly, otherwise these transmission lines, okay, they may act like an antenna and they may start emissions.
Okay.
Okay, that will cause EMI EMC issues. All
Yeah.
right,
Yeah.
so that's why this critical, this component placement is also very important. All right, so
Okay.
once you do this component placement, the next action what you need to do is DRC settings. Okay, this also
Okay.
I'm going to teach you how to do it.
Okay.
Okay, so this is like design rule check settings. So what should
Okay.
be the minimum trace width for this particular voltage or current requirement. Okay, how the copper pouring should be there. Okay, and what should be the the via size. Okay, what is vias? It's like connection between, it's kind of a tunnel kind of thing which hole you're drilling between, to have the connection between the different layers of the PCB. Okay, so anyway,
Yeah.
that also we're going to learn in more detail. I'm going to teach you, okay, how to define those dimensions, and how does that impedance, or the how does that the width of the vias or drill size, all those things will be learning closely. All right.
Okay.
Okay, and the next action in this stage 4 is that you need to do PCB stack up.
Okay.
Okay, so now you are aware about your complexity of the design of your circuit. Okay, so you may have to sit closely with your PCB layout engineer, or with experience you'll also come to know that this much complexity of the board or circuit I can design or can route in how many layers. Okay, maybe
Okay.
you want to shield them, what is shielding and all, I'll explain in anyway going forward. So you may require some extra ground layers or extra power planes. So what are
Mm.
those requirements? Based on that, you have to arrange the PCB stack up. okay, and how they are arranged, what should be their thickness, okay, and the dimensions of the PCB board, or the
Mm.
dielectric material, okay, all those things we are going to learn in going forward classes. But that is
Okay.
essential, and you need to check with your customer, okay, that if he is able to, if he's okay with this PCB stack up. Why? Because if the number of layers is more, it will increase the cost.
Okay.
Okay, okay, and if the number of layers is less, that may create problems in your EMIMC, or it can also create the complexity in routing. Okay,
Okay.
so you need to do trade-off, like which is better, cost versus this complexity. Okay, that you need to discuss with your customer and client and
Mm.
finalize the PCB stack up. And this is a dynamic process. While you're routing also, you can add or remove layers. Understood?
Okay. Yeah, yeah.
Okay, so it is not fixed, but you should have some assumption, some clear idea. Okay, like I'm okay for this much, for this complexity of the board, this many layers of the board, PCB is sufficient. Understood?
Okay.
And
Yeah.
then try to accomplish that. If not, you can increase or decrease. Got it?
Yeah. Got it.
Okay, and then finally you have to look at how this component or the mounting holes are placed. Okay, what is the orientation of the connectors, all these things should be considered in this stage 4 of PCB layout design.
And some of the pieces have most of the places whichever I have seen is immersion tin coated tin, and some of the designs I have seen such places it is gold plated. So
Mhm.
it is depends upon the how much speed it should handle that
Correct,
that board.
correct,
So that those things also will decide in PCB layout design, right?
exactly,
With fabricator.
absolutely. We'll
Okay.
talk that. Okay, we'll talk that in detail going for classes. Okay.
Okay.